In this problem, we are told that according to a poll, 60% of a nation's women ages 18 years old and older stated that the minimum driving age should be 18. And then we're asked to answer some questions about that. So to begin with, in question A, it says, in a random sample of 15 women 18 years old or older, find the probability that exactly 10 believe that the minimum driving age should be 18. Now, for these probability questions, what I would do is write my statement down. So I'm going to go ahead and just jot that down over here beside the problem. So I'm looking at what is the probability. Well, oops, let me see if I can do this right. What is the probability that x equals 10? And I'm looking for that. In the next one, we're still using the same sample, 15 women. We're asked to find the probability that fewer than 5. So x is less than 5. That's what we're looking for here. And then in the next one, we're looking for the probability that at least 5, which that means probability 5 or greater. So greater than or equal to 5. And then for part D, we're looking at the probability that the minimum driving age should be 18. This is going to be between 7 and 12 out of those 15 women that were in the sample. So this is 7, and it says inclusive, so less than or equal to x, less than or equal to 12. Now, each one of these problems are a binomial problem. So what I would do next is I would come over here and bring up StatCrunch. Okay, so if we bring up StatCrunch, let's see, I can do that. And then I'm going to plug each one of these statements in. So under Stat Calculators, we're looking for the binomial calculator. So the first problem says, okay, we've got a sample of size 15, so n's 15. The probability of success is 0.6. And we're looking at what's the probability that x equals 10. So change this to 10 and then compute. So that's our first answer, 0.1859. Then in the second question, we're looking at the same situation here. N's 15, probability of success is 0.6, but this time we want less than, and we want it less than 5. Hit compute, and we get 0.0093. And then in the next question, still have the sample size 15, probability of success is 0.6, and this time we're looking for greater than or equal to 5, and we click compute, and that's going to be 0.9907. And then the last one was a between statement, so we're looking at between, click this up here at the top, still have the same number of trials, 15, probability of success is still 0.6, but now we're looking at 7 to 12 inclusive. And hit compute, and that final answer is 0.8778. Now, I'm going to go back to the problem, and in the problem, scrolling on down, in part E, it says, in a random sample of 200 women 18 years or older from the nation, what is the expected number who believe that the minimum driving age should be 18? Now, expected value in a binomial situation is calculated by n times p. So let's see if I can come over here and jot that down. So this is what we're wanting to do for expected. Oops, let me click on something here. So for expected, we want n times p. And in this case, The number of trials and experiments 200. The probability of success is 0.6. So we're multiplying those two together, and that gives us 120. So the expected number of women should be 120. And to compute the standard deviation, the rule for that is the square root of NPQ. So here we're going to take the square root of 200 times 0.6 times 0.4, because Q is the complement of the probability. And the square root of all that is going to give us, to one decimal place, 6.9. Now, a value would be unusual if it's more than 2 standard deviations from the mean. So, when I think about this, considering the mean as being, I'm going to jot it down up here, the mean as being 120, and then if I move 2 standard deviations from that in either direction, so I'm adding this 6.9, that's this length right here, plus another 6.9. So anything beyond that, that's 13.8, so this is 133.8. So if I'm looking at a value beyond 133.8, then that would be unusual. And the same thing in the other direction, if I went subtracting 6.9 2 times to get this lower bound. But this time we're looking at 110. And since 110 is the minimum driving age, that is less than 2 standard deviations from what is expected. So this is not unusual. It would only be unusual if it was more than 2 standard deviations out from the mean. I hope this helps.